All right, good morning, good afternoon, good evening, wherever you are. I hope you're having a great day. What we're going to begin to transition into in chapter 11 here has to deal with circles. And for the most part, I'll be surprised if you guys have ever been introduced to any of the material that's in this chapter. So it's very important that you guys stay on top of what we're going to be covering in this chapter. You just don't have any previous knowledge to fall back on here. So again, stay on top of this stuff. So one of the things I want you to consider as we begin to talk about tangent lines, not to be confused with the tangent ratio within a triangle, we're talking circles now. Tangent lines is a road bike, okay? And I'm not talking about a Harley, okay, as much as I'd love to own one. I'm talking more or less about a road bike bicycle, like the one that Lance Armstrong would have cheated on, okay? And so as you think about a road bike and its tires versus, let's say, a mountain bike, a road bike's tires are very thin and also very hard, and there's two reasons for that. The main reason is the fact that we don't want to have very much of that tire touching the road. We want to have the smallest amount of tire touching the road so that we have less friction. Less friction means that we're faster. Faster means we have better results with whatever competition we're competing in. And so as I think about the road bike versus the tangent lines that we're going to be looking at, I'm going to go ahead and draw a line right here, and then I'm going to draw a circle coming off that line. Okay? Not the greatest circle there. Give me 1 second. Sorry about that. There's someone at the door. So from here, I'm going to go ahead and, again, it's just touching at one point. The difference between what we're talking about in theory here versus in reality, obviously there's going to be more than one point touching the road with a road bike. Okay? So I'm going to drop a line down to that point where it touches the road. And what I want you to think about to yourself is, what type of angle is formed here? All right? And if you were to guess a 90-degree angle, you would be exactly right. Okay? And so what a tangent line is, by definition, is a line that intersects a road, or a circle, thinking about a bike, a circle at exactly one point. Okay? And so as a result, Theorem 11.1, if a line is tangent to a circle, then the line is perpendicular, meaning the line will form a right angle to the radius drawn to the point of tangency. Okay? And everything that said right there, if that was a little bit confusing, is what we just talked about up here. Okay? All right? So whenever you see a tangent line on your paper, you want to draw a radius to it and make sure it's a right angle. Okay? So as we look at numbers 1 and 2, okay, number 1, I want to draw a right angle in right there. Okay, before I even get going, because I know tangent, radius has to be a right angle. Over here, I want to draw a right angle and a right angle before I even get started, because I know that has to be true. Now from there, in order to figure out what x is going to be, you probably already have a good idea, but we have a triangle here, and we know 180 degrees is always within a triangle. So if I take 58 and 90 from the 180, you're going to end up with 32 degrees for the value of x. Okay? The difference between 1 and 2, in number 1 we have a triangle, in number 2 we don't have a triangle, we have a quadrilateral. Now remember, how many degrees does a quadrilateral have? It has 360. If you don't remember that, you can always fold it into two triangles here along this line. And so as a result, 180 plus 180 equals 360. And so to solve for x, you could take 360 and subtract 130, 90, and 90, and you can get your answer here of 50 degrees. Okay, so again, not hard stuff right there. Whenever you have a radius to a tangent line, it has to form a right angle. Now for number 3 down here, if you're not sure how to go ahead and figure out what x is going to be, okay, first thing I would do is draw on those lines right there. Now, if you notice, all the angles are congruent out here on this polygon, okay? And so as a result, I know that all of these angles are also going to be congruent. This is a regular pentagon, okay, regular pentagon. So in order to find out what the value of x will be, you can take 360, which would be the distance from here all the way back to there again, and divide that by 5, and that'll be the value of x, okay? So x is going to be 72 degrees, and that's what you get there, 72 degrees for that. And that one's pretty much straightforward. Now, for the rest of the page, let's actually scroll down. We're going to skip 11.2 for now, and we'll come back to it here in a second. And number 4, I see one of those tangent lines with a radius, so I know it's got to be a right angle. Number 5, I see a tangent line with a radius. I know it's got to be a right angle. And in number 6, I see a tangent line with a radius. It has to be a right angle. Okay? Now, we're going to talk about the equations, but I'm going to encourage you, once I write out the equations for all 3 of these problems, to go ahead and pause your computer and see if you can solve them algebraically, because you need to know how to do the algebra in this chapter. For number 4, 5, and 6, all the triangles are right triangles. Whenever there's an unknown within a right triangle, the Pythagorean theorem should come to mind. And so as I look here, I've got this side squared plus this side squared is equal to the hypotenuse squared. Okay? For number 5, I'm going to go ahead and fill in the radius length. Okay, they're telling you the radius for a reason. So it's going to be leg squared plus leg squared is equal to, and I probably should have done this on the first one by identifying, don't confuse this with 2x, but it's x plus 2. Okay? And then the last one, again, they're telling you this radius length for a reason. It's going to be a length of 9. So you have leg squared plus leg squared is equal to, ignore that, is equal to hypotenuse squared. Okay? So, like I said, there's your equations. I'd like you to go ahead and pause your computer and see if you can go ahead and solve those. All right, well, hopefully you were able to solve those 3 problems. Let's see how you did. First of all, looking at what you guys did 2 chapters ago when we had to FOIL these, success rate is a lot greater if you go ahead and write them out. I'm just telling you, it's a lot greater. So if we go ahead and work this out, x squared we have 64. If I FOIL this, that's x squared. That's 2x. That's 2x. And this is 4. Okay? Now from there, I'm going to try to get the x squareds to one side because it might be a quadratic. If I subtract x squared, those guys are gone. So to simplify this, we're going to combine those 2. All right? And that's how we get the next step. Now, you guys should be good from there if you weren't already. And then divide through by 4. So x will equal 15. Okay? Now, if you look at the picture there, is that picture drawn to proportion? Absolutely not. And so you got to be careful. Sometimes the pictures are not drawn to proportion. So number 5, if you work that one out, subtracting 9, and then square rooting that. Okay? If I was to leave that in simplest radical form, does 91 have any factors that go into it? Let's see here. Divided by 7 goes into 91 13 times, but 7 and 13 are both prime. So I could leave it like that, or nearest 10th place, let's see here, 9.5 the approximation of that length, okay? And that looks a lot more realistic, more so than number 4. All right, now the last one. Again, if I go back and I do what I did up here, just to make sure that I've done the algebra correctly, to keep yourself safe, I would go ahead and write it out like this, okay? And so from there, here we have x squared again, 9x, and this is 9x, got a little ahead of myself, plus 81, okay? Now from there, I've got only 1x squared, so it is going to end up being a quadratic. So I'm going to take 81 and 144 and add those together. Okay, that gives me 225 equals x squared plus 18x plus 81. All right. Now, because it's a quadratic, I got to get everything to one side and set it equal to 0. So I'm going to subtract 225 from both sides. So that's going to be x squared plus 18x minus 144 is equal to 0. Now, you can either use your quadratic equation or you can FOIL that. So we have x, we have x. Factors of 144 that would have a sum or difference of 16 or 18. Let's see here. 24. So let's go with 6 and 24. If I do 24 and 6, this is going to be positive and negative. Here's why. These two have to have a product of negatives. So one's positive, one's negative. The middle term is positive, so my larger of my two numbers is going to be positive. So from there, since the product of these two is 0, x plus 24 equals 0, or x minus 6 equals 0. Okay? I'm going to subtract 24 from both sides. I'm going to add 6 to both sides. That's my answer because I can't have a negative length, and it looks proportional for the picture as well. Okay? All right, now we did skip 11.2, which basically is the converse of what we were talking about in 11.1. And so in 11.1 it said this: if we have a line tangent to a circle, then there is a point at which the radius will be perpendicular to that line of tangency. This one says this: if a line is in a plane of a circle is perpendicular, meaning it forms a right angle, to the radius at the end point of the circle, then the line is tangent to the circle. Okay? If it forms a right angle on the circle, right there at the point, the line has to be tangent to it. So it's just the converse of that. All right, now let's go ahead and go to the back side. And you know how I started the lesson by talking about bikes? Okay, the road bike versus the mountain bike and why it has the skinny, narrow, hard tire. Number 7 is kind of like the gear shafts of the bike. And what we're given is this: the distance between the two bikes as far as the chain is going to be 25 units. And the question is how far do you put their, see if I remember my science term correctly, the fulcrum? Is that right? Have you got your crank and your fulcrum where it actually, the force is focused on? So in order to figure out the distance here between those two, you know, your bike pedal and the actual gear shaft on the second tire, there's a couple things we can do. One, again, I got a line tangent to a circle, so I'm going to go ahead and show that those are both right angles. Now from there, I'm going to go ahead and draw a line that's parallel to this line right here. Okay? The reason why it's got to be parallel is because this angle is a right angle and this angle is also a right angle, because those are same side interior angles, these two, and they're also supplementary. Same with these two. They're same side interior, so they're supplementary. So as a result, if this length is 9, well, as a result, I just created a rectangle. So if this length is 9, then this length is also 9, and so this length right here is going to be 3. If this length is 25, then this length is 25. So we basically have this right triangle, and I'll redraw it so we can see everything. And now you can go ahead and solve for x to figure out the distance between those two fulcrums. So uh, 25 squared, is that 625? Yeah, right. Okay. Adding that together, we get 634. And you can square root that. And then from there, we can simplify that radical. It's pretty large. Let's just go ahead and round to the nearest tens place. 25.2. Okay, it's a length, so it's going to be units there. All right, so what I'd like you to do, see if you can do that for number 8. Figure out the distance this time, how long the chain will be between the two, I guess you'd call them pulley systems, the two circles. Okay? Take a moment and see if you can set that up. All right, hopefully you paused your computer and you were able to take a moment and do that. For number 8, I'm going to do exactly what I did for number 7 in drawing in my line parallel to the other one. Okay? This then creates a rectangle in which if this length is 2, then this length is also 2, and this length will be 1, and this length will be x. So if we have that right triangle there, 1, x, and 7, we can go ahead and solve for x. So 1 squared plus x squared equals 7 squared. You have 49 minus 1, that's 48. The square root of 48 in simplest radical form is going to be 16. 4 times 4 is 16 times 3. So you have 4 radical 3. Or, nearest tens place, you would have 6.9. Okay? 6.9 or 4 radical 3. All right, so again, just need to make sure you understand tangent line to a circle, the radius at that point is going to be a right angle. Okay? The last two problems I want to make sure that we touch on is this. If we describe, what are we describing here? Tell whether each polygon is inscribed or circumscribed about the circle. In this case, it's on the outside, so don't forget that that means that it's circumscribed. Okay, and this one is on the inside, so that is inscribed. Oh, inscribed. All right, so your homework is actually online, so you can double check it there, but I just wanted to make sure that you had some good background information to go off of. So good luck with the homework. Make sure you have that due for the next time we meet. I'll see you later. Good night.